Hi, I'm back again, and now we're going to cover the slope-intercept form of a line. This is section 6.4. I hope I didn't accidentally delete your first one. That means I have to go back and restart it. I will let you know that later today when I go find out. Anyway, in the slope-intercept form of a line, we are looking now at graphs of lines. Lines are straight. In a graph, this is your x-axis, this is your y-axis. One type of graph, it's called a direct variation, is when it goes through the point 0, 0. And so it's just basically as it goes up or as it changes, it's going up or down depending on what you're doing there. But in a direct variation, it does go through the point 0, 0, and it only has a slope. And in a formula, we call the slope, this M stands for the slope of that line, the rate of change of that line. Okay, so direct variations are very easy because the only thing you have to do is figure out how much did it go up and how much did it go over. You know the slope, so you can put it in here. Okay. The other kinds of lines that we have are lines that don't necessarily go through the origin. Okay. They might start up here. So what we look at on those, they still have a slope. Okay, this one has a slope, and it goes through the origin. Okay, this one has a slope. It doesn't go through the origin, but it does cross the y-axis. So it crosses the y-axis. So any that don't go through the origin always cross the y-axis somewhere. That we call the y-intercept. It's called the y-intercept. Okay. So in our slope-intercept form of a line, if it doesn't cross the y somewhere, it goes through the origin, you don't have a number added. If it does, you have a number added that is that value of the y that it crosses. So this B stands for the point it crosses the y-axis, otherwise known as the y-intercept, hence why this is called intercept form. This M is always the slope. And these x and y stand for the different variables that make the equation true, that are on the line. The x and y are points on the line, so they change. There's an infinite amount of them, so they change, so we leave them as x and y's. We do find numbers for M and B. Those are numbers that go specifically with a certain line. And so we try to determine what is the slope and the y-intercept for this line. It gives us a better way of doing that. I'm going to pause this for a moment. Okay, so what we're going to do is just kind of learn some basics of this, learn how to look at a graph, figure out what the slope-intercept form of that line is, and then also if we have a slope-intercept form, how to graph that. So those are the 2 points that we're going to look at. And again, these are set up to show in picture form and in formula form what is a representation of some certain situation. It may be population growth and we're making predictions. It may be how much something costs and we're making predictions. Or we've graphed 2 different ones two different price schedules, and we see, well, where does it make sense for us to use this schedule, or where does it make sense to use this schedule, depending on what your slope is and where you start. So let's just start with a direct variation so you can see this. This is a direct variation. Okay. An example of a direct variation is basically your weight. Your weight increases, especially as a child, but at the beginning, well, we're going to start at the beginning as being 0, but yes, there could be a weight that you start earlier. But let's go with that. So your weight versus time, because it's really hard for us to measure in the womb, but we're going to just start with this as a direct variation. So time is almost always used as the x variable. If time is involved, it's almost always use as the x variable, because that's called the independent variable. Time goes on no matter what. But our weight increases based on time. Sorry about that. Lots of phone calls with the death of my mom, so I just apologize for those interruptions. I don't intend for them, but it's just one of those things. I do have to take some of these. So this is our weight over time, okay? And that's pretty much a direct variation. It's a positive slope, mostly, because when we start, it usually goes up. Most people, well, technically a few people do lose a few pounds or a few ounces right after they're born, and then they go up. But for most intents and purposes, on average, it goes up per day. And they actually chart this. How many ounces are you growing per day, or how many ounces are you growing per week? Because it's to show that you're getting the nutrients that you need in your body. So this is a very common thing that they track. And they started at basically that let's just call it the weight gain, okay? So weight gain would be 0 at 0 times. So it's a direct variation. It's going to go through the origin, because at 0 time, there's been 0 weight gain. So this is time, this is weight gained. Okay. And so let's say let's do these as weeks. That's 5 weeks. And I'm going to play really ignorant here, but let's say that we gain on average 8 ounces per week. I don't know if that's too much, but we'll go for this just because I'm throwing this out in the air. So let's say by week 5, we know we've gained, that was pretty bad, 8, 16, 24, 32, 40. Okay, so we know we have gained at 5 weeks 40 ounces. Okay, so here is our graph. That's a picture of our graph. So to make an equation for this, an equation that represents this graph, we know it goes through the origin. So if that's true, we only have to find the slope, because that's our formula for the slope. That's the only thing we have to find. But what we do remember is on slope, it's how much did the y change? So in this case, it's the ounces changed over how much the x changed, and that would be the number of weeks. Okay, and so in this case, The ounces changed was 40. Of course, we are going up in ounces because we're gaining weight, and it's over 5 weeks. So that is our slope, which we actually can reduce down to 8. You can leave it as 8/1, so it looks more like a slope, but typically, because it's a whole number, we would write it as 8. So the equation for this graph that represents how your baby is growing would be y equals 8x. It does not cross the y-intercept, it crosses the origin. So we only need to find the slope. We found the slope because it was the number of ounces that changed over the number of weeks that changed. It reduced to 8/1, which is the same as 8. So our equation here would be y equals 8x. And so we would then track that to see if that's consistent. If it goes down for some reason or goes up for some reason, they want a pretty consistent rate of gaining of weight. You don't want it too fast, you don't want it too slow. So they're going to look at that over the weeks, probably for the first 3 months. And that's what they're looking at, is just to make sure the baby is getting the nutrition and supplements that it needs. Okay, so that's one way of doing it. Another one is when it's not a direct variation. So this is basically what I call all other lines. And for this, we are going to use the old scenario of renting a truck. Okay. This is renting a truck for moving. A lot of times the price is about $125 as a flat fee. We just have to pay the flat fee. And then there's an additional charge per mile. So if they say it's 0.35, that's 35 cents per mile, then that's an additional charge. Okay, so if we look at this, if we were to graph this, it's basically kind of like this. I'm going to draw this little line here to get to 125. Those little squigglies say I am actually shortening it so we can just see up close. It's like zooming in on the computer. You zoom into the portion so you can see it closer. Okay, I'm not going to do this. This is going to be per mile. I'm going to go by 5 miles at a time. So 5, 10, 15, 20, 25, 30, 35. Okay, we're doing this around town. So, we might not go more than 35 miles. Okay, but what happens is this is our cost of renting. Okay. And it's $1.25 plus this 35 cents per mile. And that's for wear and tear. The more miles you drive it, the more wear and tear on the vehicle. So that's what that is really for. Okay, so the first 5 miles would be 5 times 35. So it's going to be 125 and 30, 155 or $1.55. So if I wanted to, I could say this is 126.55. Okay, and so those are just how we look at that. It would consistently go up at a constant rate, and you would have the rate drawn there. Okay, now, but because we've been given the information here, we can actually write the equation. Remember, the equation starts where it crosses the y-axis. Well, that is our starting point. The y-axis is our starting point. Okay? That's basically, it's the flat fee. It's charged no matter what. Then the amount that's charged varies depending on how many miles you drive. that is the rate of change because that changes how much we have to pay depending on how many miles we drive. And so that's our rate of change. Okay, so in this case, it's y equals mx plus b. B is, and don't ask me why B is the y-intercept, but it is. Accept it, memorize it, make sure you know. Okay, this is where it crosses the y or the starting point. Okay, so in this case, this is B because it's our starting point. It's where 0 miles driven, you pay still $125. Okay, it's usually called the basic rate. Here is my rate of change. I'm really given that because it says they're going to charge me 35 cents for every mile I go. So they're going to charge me $125 plus 35 cents per mile. 35 cents or 0.35 is actually our M. It would be over 1 mile because it's per 1 mile. So I know now what my slope is. This is my change in cost, or the rate change in cost per mile. Okay. In this case, y is the cost, x is the miles. You notice that? I marked that on here. Miles, cost. Miles is the x. Y is the cost. So our equation that represents this truck rental is 0.35, because that's how much they charge per mile, plus the flat fee of $125. And if you notice, that goes along with my graph. This is the starting point or the y-intercept where it hits the y. This is how much it's changing depending on how many miles we drive. And this will be the total cost that we get at the end of that. And so that's basically the slope-intercept form. Now, let me show you, if I just give you a picture, a graph, how do I find the slope-intercept form? So let's say I have this graph. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. We're going to stay, it starts at 6 and it's going down this amount. So this is my graph. Okay, so this is my y-axis, this is my x-axis. The first thing I notice on this graph is that it's going down. This is going to be a negative slope because from left to right it goes down. Okay, so there's two things I need. I'm trying to get the equation. I need two things. One, the slope, which is written as M, which remember is the change in y and over the change in x. Two, I need where it crosses the y-axis or where it's starting point at 0. Sometimes that's harder to see. This one I've driven it up so you don't really have a true starting point. So it's easier to find the cross where it crosses. This is my B. So I'm looking for M and I'm looking for B. That will give me the equation for this line. Okay, so I'm going to start with B because it's very easy to see. This line crosses Y at 6. If I look at the y-axis, the point on the y-axis where this line goes through is the point 6. So my B is going to be 6. Okay, the next thing is now I need my slope. Well, the slope is the change in y over the change in x. I've made this pretty easy. I go down 2. That makes it negative, which I knew it was going to be negative. And I go over, I think I didn't draw that one correctly. Let's see, what did I go over? Well, you know what? We're going to do it this way because it's easier. We're going to go down 6 and over 4. Okay? Because if I look at this, I did go down 6 and I went over 4. That's a much easier to read than my mishmash of a graph that's kind of hard to read. So I'm going to read the points I really can see. And so this reduces down to -3 halves. So I now have my slope. I can write the equation that represents this line, and that equation is y equals -3 halves x plus 6. That's not a b, should be a 6. Okay, that represents anything that's on this line. It will tell you if you put in a value for x, what the y is going to be. If you put in a value for y, what the x is going to be. So it gives you both things. Okay, so those are the things that we're looking at in this. You should be able to both take it from a graph and find the equation. Oh, I didn't show you how you go from a graph or from an equation to a graph. Let's do that very quickly. Okay, so that was from graph to equation, and this is from equation to graph. Okay, so if I have y equals 1/2 x minus 2, a little bit different. Okay, if I remember, this is my m or slope. This is my change in y over my change in x. This number here is my where it crosses the y-axis. Now, when we're looking at this, we have to take its sign. So its sign here is -2. It's a -2, so that means our y-intercept, our b, is going to be -2. So step 1 is always find the y-intercept first. And so here, I'm going to go down 2, and I'm going to plot my point, because I know that's one point on the line. Because it is the y-intercept, it is where it crosses the y-axis, so I know that's a point on the line. That's one point. The second thing is I find my slope, so my m is equal to 1/2. That means from B, we move B, the point on the y-axis, we move up, down, left, right. In this case, we're going to go up 1 and to the right 1, because a positive 1 is up, a positive 2 is to the right. So we are going to go up 1, we are going to go across 2. That is my next point. I could continue to do that. I go up 1 and across 2. There's my next point. I could go again, up 1, across 2. That would give me my next point. If I wanted to go the other way, -1 over -2 is equal to 1 over 2. So I could go down 1 and back 2. And notice this all gives me a nice straight line. And that is the equation that represents this line and this line only. You can't write a different line. That is the only line that is represented by that equation. And so we went from the equation, we find the y-intercept, we find the slope, we plot some points, and we connect them. And that's the line that it's representing.